Hello, statistics class. It's Dr. Hux. And what I want to do here is show you, and there's probably a better way, how to make an APA formatted table out of these tables in SPSS. Here's a table that I have right out of SPSS from a student. And these were calculated in crosstabs because this is getting ready to be a chi-square. This is the data for the chi-square. But I put in here, remember that in all submissions from this point on, the tables are to be in APA format. So if you put a table in something, it has to be in APA format. That table, when you put it in APA format, looks like this table. And did I spell that word wrong? Italicized. No, I just capitalized it. It didn't like it, did it? Okay. But anyway, you have a table number. If this is table 1, it's written in regular font, Times New Roman 12 font. But then the title is italicized. Then everything else is regular font. And really, I probably need to change this font to Times New Roman, because that's what's expected, and size 12 if you can get it. Sometimes you can't, and we will let you take it down to about a size 11 to get everything in there. But you want your table, anything you can needs to be in Times New Roman and font 12. But anyway, let me show you how that was done. I took this table right here, and I just blackened the whole thing in. Well, I'll get that done here in a minute. Let's see. I got to get all this covered, but I don't want anything outside of it. And then I right click on that. And then I go to table properties. And then I put borders, and I pull this little thing in here, see? And the first thing I do to a table like that, that's got all these lines in it, I just hit that button right there. And notice that that took all the markers away from this. Then I change this to 1 point font. I mean 1 point, yeah, for the thickness of the line. And in an APA table, you need the top line and you need the bottom line. And you can't kind of pick one out. You have to do it this way. So you go that way and you go, okay. And then you bring that up here so you can see it. Okay. And look what you've got now. You've got this part of the table. Well, what you do then, you can do a couple things here. Let me see which way to go. Sometimes it's better to go one way than it is that. Go like that, because you want to put one continuous line across here. So you right click, you go to table properties, you go to borders and shading, and that's still on 1 point. And up here, I need a line, so I'm going to put that up there. Okay, okay. Now, I've got an APA table, except I'm going to have to undo all this after a while. Let's see, I'm going to have to do the font on this. Let's see, where can I do that? Oh, I have to go up here and do it. So I'd go up here and do Times New Roman, and then I would hit, I'm going to put that in 11, but anyway, you've got a nice table there that's in the right font. Let's see, let's come down here and see what other tables we've got. Oh, there's that table where I did it italicized, HO1, there is no significance. Here's the hypothesis. And we ran these, that's another thing, when you run these chi-squares, you need to run those in legacy dialog. So you have to go through the process and hunt that down, because it's better than I think it's better than the new stuff. I was pointing out this significant result. What I could do here, I could make this table. No, I printed that as a picture and put that in there, so I really can't change that one. But here's another table that could be changed. And again, let me do that again. There's another example. You just color that in, right click with your mouse, table property. It doesn't take long at all. Before I learned this, I worried myself to death doing this. Borders and shading. And then look, see this right here? I don't want any of that stuff. So what I do is go up here and say none. I don't want it. Then I come back down here and change this to 1 point. and then I put the top and the bottom on it, and I go okay, and hit okay. And I wish there was a better way, and there may be. And if you guys know one, you tell me, okay? Well, can't do that. So here, let me do this. I just color this into. You can do that up there, but it sometimes, because there's an empty space here, it's difficult to do. But anyway, colored in like that, or shaded in. I guess I don't know why I said colored in, but shaded in. Go to table properties again, borders and shading. Well, look, you've got a line missing up here, so hit it, and okay, and okay. And how much time have I used up? Almost 6 minutes. And that's how that's done. This is a chi-square cross tabulation table, and for you people doing that, because we're not doing, there's another step in the chi-square when you've got this many independent variables. You've got year 1, year 2, and year 3 here, and then you've got all these reasons across here. It's kind of like you need that Tukey post hoc test to tell you if you get this significance value, which we got up here, we had some kind of significance on this. And when you get that significant value, oh, here it is. The Pearson is 0.030, and the likelihood ratio is 0.013. And we've talked about those in this course. And what it says, 6 cells were have expected counts less than 5. You know, that's a bad deal, except you can go to the likelihood ratio, and it's even better than the Pearson. So you've got significance here is what it amounts to. But what I did, I actually took this table right here, and I put it in SPSS and made this table so I could talk about when I have significance. I want to know. I look in there and I say, well, what's significant? So what I did is made me an extra row in each one of these places, the absolute value of the actual count minus the expected count. And I may put that in another video later, how to do that. And I got these values. And I thought, well, what we need to know, since we know this is the relationship is significant here, that we're going to do away with, we're going to reject the null hypothesis. And the null hypothesis is that all these expected values will be similar. But I found the high and the low. And for year 1, 5.1 was the difference between the actual count 10 and the expected count 15.1. And what I did is when I wrote this up, helping this person, I said a chi-square test of independence was calculated comparing the frequency reasons teachers left the profession and expected values for the reasons teachers left the profession after year 1, year 2, and year 3. And then I went through a significant intersection was determined. The chi-square of 10 degrees freedom 10 was 19, but the probability was less than 0.05. That's what that. However, because the number of cells having less than a minimum count of 5, the likelihood ratio was done, and we did it and said that's significant. Among those leaving the profession following the first year, better offer was the most chosen reason in the first year. For those leaving the profession, I'm thinking about the depression, I guess, leaving the profession following the second year of teaching was spouse relocation, and better offer was most frequently chosen reason following the third year. Then you would go on and specify, because I didn't have time to do that. I was going to get to you people. Anyway, that was a third hypothesis that I couldn't figure out what that one was about, so I couldn't help with it. But anyway, that's a way to do that. So good luck if you want to use that process in making tables.